So good morning, everyone. Myself, Gokul Prasad, Assistant Professor, Department of ECE. So right now, I'll move on to the video lecture series on the subject Analog and Digital Communication. Subject code is 23ECB302. So today, we'll be discussing about angle modulation. So basically, angle modulation it is one of the basic thing where frequency and phase modulation is combined to form an angle modulation. It is most essential thing for signal transmission perspective. So here in this angle modulation, that is basically a carrier wave is varied in accordance with the message signal or modulating signal or original signal. So in that carrier, with respect to the carrier, angle of the carrier is varied. Angle in the sense it is a combination of frequency and the phase, right? Frequency or the phase of the carrier wave is varied in accordance with the modulating signal, right? So here this are the basics of the modulation. So modulation is one of the predominant thing which is needed for signal transmission, and demodulation is needed in the signal reception side. So for that we'll be going with the transmitting antennas. So we'll be going with the smaller antennas, and multiplexing is also one of the most important thing which allows the multiple signals to share the single channel. And moreover it is used by accommodating these type of smaller antennas and multiplexing technologies, the interferences can be easily avoided. So right now we'll recap the AM. Right, in the AM it is very much susceptible to noises and interferences. In order to overcome that, we'll be moving with the angle modulation mechanisms. So now, as angle modulation is considered, the amplitude is constant, and moreover, when compared with the amplitude modulation, this angle modulation provides a better noise immunity, so that it is more widely used in more number of applications. For example, say when you are going with FM, it is used with FM radio broadcasting like that. So coming to the phase modulation, so here the carrier phase will be varied, which is directly with the amplitude of the modulating signal. So there are certain key parameters which we should focus, such as carrier amplitude, right, phase deviation, as well as the different characteristics will be focused over here. So here this phase modulation plays a major concern in this digital communication field. So coming to the comparison between the FM and PM, right? So here, when you are going with the frequency modulation, the mechanism what it is used is it varies the carrier frequency, whereas when you are going with the phase modulation, it varies the carrier phase. So the amplitude remains the constant for both the cases, frequency as well as the phase, right? When you are going with the frequency modulation, only the frequency of the carrier will be changed, whereas when you are going with the phase modulation, the phase of the carrier will be changed. Comparing to the next parameters, that's about the noise sensitivity. Frequency modulation is less sensitive, and moreover, FM is also the same. Okay. Coming to the analog use, it is most usually used for voice as well as music. So it is whereas frequent there is the phase modulation is less commonly used. When you are going with the digital domain use, it is less direct. Frequency modulation is, whereas phase modulation is preferred for data, right? So this is about the comparison part. Coming to the advantages of angle modulation, so as I said, angle modulation is much more noise immune when compared with the AM, that is the amplitude modulation, and moreover it is more the fidelity have been improved with respect to the angle modulation. So with this wider bandwidth node enables the better SNR, so that it will be providing the enriched quality with respect to the audio perspective. So coming to the power, it provides a more efficient and use of power with respect to the amplifiers, thereby reducing the energy consumption and heat. And moreover, by employing this angle modulation, the interferences is drastically reduced, so that it will be most widely used for different type of applications too. So coming to the real world applications of angle modulation, it is widely used in FM radios and analog TV, two-way radios, for example, say public safety systems. In satellite communication also, in order to uh, reflect against that is the resilience against the fading and noise. This is most widely used in satellite communication too, and even in the radar systems, which is used for Doppler shift measurements. So conclusion about the impact of angle modulation is, so it provides a better noise immunity when comparing with the AM methods, that is amplitude modulation. So by that employing this particular angle modulation, it is highly resistant, so that it is highly fidelity against the analog and digital communications, and paved the way for different digital schemes like QAM, PSK and all, and moreover the robustness is drastically more when you're going with the angle modulation, so that we can able to achieve a higher signal quality at the transmission end. So coming to the assessment part, in telemetry applications like spacecraft data transmission, FM is preferred because it is less affected by amplitude variations in order to noise, right? So coming to the 4G next question, 4G LTE systems, angle modulation plays a role in using phase and frequency changes in OFDM subcarriers, that is orthogonal frequency division multiplexing subcarriers. So this is about the assessment part. So that's it. Thank you.